Hello guys, and welcome to this video. This video is going to be about touch switches. Now there are moments you just want to control something with the touch of your finger. Maybe you want to send a pulse to a particular circuit. This video is for you. If you want to see how I made my own touch switch and added it to one of my boards that I have, stay tuned till you see everything. I am the Electronic Prince, and let's begin. Okay, first off, I connected these two transistors, which are NPN transistors, as Darlington pair, so that I can have very high gain, because it is my body's electric charge that is going to run the whole circuit. So I'm having respectively as my emitter, my collector, and my base. So I'm going to connect this on the breadboard with a power supply of 5 volts and an indication LED to show that the whole circuit is working. So now my indication LED on the board and the Darlington pair. This pin here is the collector which is going to go to the negative side of the board of the bulb. I'm going to connect it to the bulb via a resistor so that it will limit the current going to the LED. Then the emitter of this Darlington pair is going to go to the negative side because it's an NPN transistor. Then the base is what I'm going to touch to power the whole circuit. Now this Darlington transistor is in NPN configuration, means it needs a positive voltage to pass negative to power this LED. So my body will be the one to conduct the positive from the positive rail of the power supply to the positive input of these Darlington pair transistors. Now I'm going to just connect a positive jumper to the positive parts, so that I'm going to have two terminals for my touch. I can attach this to any two pieces of separate metals, so that when I touch, it bridges those two metals. But first, now because this is a test, I'm going to just charge the two of them. And okay, I haven't completed my connection of the LED. Okay, I need positive to complete the LED circuit, which will go to the positive side. So now touching it, when I touch the two of them, you see the bulb ons, it glows, because I'm conducting the positive from the rail supply to the P channel of this Darlington pair transistors. So because of its two transistors configuration, it amplifies this my input positive, no matter how small it is, to give the bulb a glow. That means pass a higher current to the bulb. Now this circuit is very useful, but there can be disadvantages because it can have problems with interference from AC lines. Because of this circuit, I have to shut down all my AC lines that are running through here, because if you make this circuit using any AC adapter, the circuit will work if you just only touch this transistor positive input pin, which you will not see likely as a good thing that your circuit is working. So if you want to know if your circuit is working perfectly, shut down all form of AC lines and use a battery or any form of power bank to power up the whole setup. As you can see now, because I am using battery, my body is not enough to power up the whole Darlington pair. But when I conduct the positive from the power supply rail to the positive input of the Darlington pair, you can see that the bulb glows to show that this circuit is working. Now I'm going to attach this circuit to my power bank board, because my power bank board needs a bridging of two contacts before it can start bringing out its 5 volt. But because the button is damaged, I'm just going to attach this so that this will be permanent circuit for that booster, so that I can just touch and power up the booster's output. So let me show you how I did it. Okay, now this is the circuit, my power bank circuit, which I've been using to power my breadboard for all this time. I was showing you the project on the breadboard. Now this is the power bank circuit I've been talking about that I want to use the circuit for, because if you look at these two joints here, was with a button. There was a button here, a push momentary button, which when you press one, it just powers up the power bank so that it can have an output voltage. But now the button fell off due to some mechanical press and so on. So that's why I wanted to replace this button part with this touch circuit. But now for me to power up this power bank circuit, I just have to put a wire to bridge these 2 points for maybe a tenth of a second so that it can open up its output for charging any mobile or power up any product that needs 5 volts. So I just need to bridge these two, which is why I want to replace it with this my touch switch. And when I checked, this connection is just the pulling of an IC pin to ground. Yes, when the button is pushed, it pulls an IC pin here. This IC, which is covered by this rubber band, it pulls one of its pins to ground, which makes the output to turn on. So if it does that, that means I need an NPN transistor configuration so that it will only connect negative to this IC, which is a perfect match for the circuit which I have just made. So I'm just going to connect this to it and we'll see how it functions. Now I've just checked my transistor base and I have seen that there is a single transistor that can replace this setup which I have just done here, which is the BC517. Yes, the BC517 transistor is a downloading transistor which can easily replace this pair, which will save me some form of electrical noise that may interfere with this circuit. So I'm just going to desolder this setup and solder this one right away so that to make my circuit look more simple and efficient. So I'm just going to take out 3 wires from this place. There's 3 wires. Alright, taking out 3 wires and I'll just attach them to the transistor, which I'll just solder to it. Okay, making sure to be very careful so that I don't overheat the transistor. So I'm rushing everything very fast so that the transistor will not be damaged. Okay, one step away. Alright, I'm done. And based on the pinout of this transistor, it is collector, base, emitter, as you can see from left to right of the transistor. So I'm just going to solder it to this my power bank pad. So the power bank, as I've shown you before, has 2 pads for sensing the touch, which is these 2 pads. So I'm just going to solder it between these 2 pads of the board. So doing that, the collector goes to the pad going to the IC, because the IC is going to collect the negative side of the circuit. Then the positive to go to the other part of it. See, the power bank is already turning on because of noise. So this last pin, which is the positive, is the one that's going to have contact with the positive side of the battery so that it can power up the circuit with just a touch. So if I touch in between these 2 wires, it will energize the circuit because of the amplification of the transistor. So right now the board is already on, but I'm just going to wait for it to off and I'll touch it and see. Okay, as you can see, this is 2 pins, so let me just touch in between them and see what happens. You see, the board comes on from just the touch. You see the blue light, if you can see it clearly. By just touching between these 2 things, it comes on. Well, this is one of the ways in which you can make a simple touch switch. Well, this one is not a latching type, and a latching touch switch will be a topic for another video. Now, if you want to make this your circuit to be more efficient and work well for you, you should make all the wire links to be very short, and you can add a pull down resistor of more than 200k so that it can pull down the base of the transistor when there is no touch, so as to prevent external voltages to tamper with the circuit. Now I'm going to make another video of the latching
circuit, so I need some time and some resources. Consider supporting me through Patreon, and thank you for watching this video. See you next time.